Okay, there we go. We got audio now. Sorry about that. Cool. Awesome. All right, so like I was saying before, your transforms. If you just want to move something like 3 meters to the right, what you would normally do is you would have a speed float and your transform dot position, and you'd move it over. But with your transform, you have all this other crap that you don't really care about, but that all gets passed around in memory as well. So the new way of doing things with the job system and the entity component system, they are not the same thing, but they're often used in conjunction with each other. So like I was saying, the job system is data oriented. Its main purpose is to fully utilize multi-core processing and also multi-threading. There's zero garbage collection because everything is passed around as value type structs, so you don't have to worry about that. The ECS system, what Unity is touting this is as performance by default. So it's actually hard not to write optimized code in this way. Everything is highly modular, as you'll see, and everything is tightly packed in memory. You remember from the first slide where references were passed all over the place. With the entity component system, it uses what they call native arrays to pack in all of your components in memory, like contiguously. This is kind of a rough outline of how the entity components works. What you'll have is an entity, which is really nothing but a container for components. The entity itself is just an ID. It doesn't even have a name to it. It will contain a number of components to it, and each component does single function, or it actually just contains a single data point. And then you have your system, which will take these components and then will actually do the process to it. Your systems will pass it over to the job system if you're using it. Like I said, you don't have to. And then that will schedule jobs as threads to wherever you want to send it to. Okay, so we can hit up the actual demos. Now, if you want to set this up for yourself, the first thing you actually have to do is you need to go into, first you actually need to edit your manifest, which is also new in Unity 2018. In your root folder, above your assets, you have the packages folder. This manifest is just a JSON file, really, that contains what is going to be in the actual package manager. Because entities and jobs are in preview, you have to go in and edit this manually. It won't show up by default. Once you have that added, you go into your package manager. And you'll see entities here. And you can see it's preview. Oh, snap, I can update. I am not going to do that. And you'll see it up here at the top. That is in preview packages are in use. So this is really not ready for production. There's also a lot of functionality that's missing. And I'll show you what that means here. So there are two ways to implement the entity component system. There's what they call a hybrid ECS, which still kind of utilizes some game objects just to make it easier to handle it. And there's pure ECS, which is done all in code, which I think is only for crazy people. So this is a demo that, or a tutorial really, that I found online that really demonstrates how these approaches differ. So this is just the classic way of doing things here. And I'll show you how you get performance improvements for these. So right now, this is just, let me see where. All I have is this little simple script on a game object, and we're just going to spawn a couple thousand of these. Visual Studio. I thought I had Visual Studio Code on here. Oh God. There we go. So all this is going to do is just move the game object forward until it gets to the bottom of the screen, and then it's going to just respawn it back at the top. Super simple stuff. And you can see here, every time I hit spacebar, it's going to spawn another 500 ships. And as you can see, I'm getting about 160. We'll keep going until I get about 30. So about like this on my laptop. This gives us 5,000 objects. Justin, write that down so I don't forget about it. So I want to show you what it does in the job system, which is basically, let's see, open up. It is just going to take our same game objects, but it's going to split it up over the processors. If it decides to open up. Nope, I'll show you that in a second. So our enemy ship is basically the same ship, but it doesn't have the movement component on it. That is going to be handled by our movement job. You can see here that the movement job itself is just a struct that implements this interface called job parallel for transform. This is like a built-in struct specifically for the job system for manipulating transforms. Now, this isn't the transform class that you're used to. This is actually just a struct that has local position, local scale, rotation, and I think that's about it. So it's really optimized to be running in parallel. Visual Studio just crashed. Lord. All right. Okay. Can y'all see that pretty well? So the game manager is pretty much the only mono behavior that's in this scene. And the first thing that I do here after declaring all the variables, it's on disable, you want to make sure that the job is completed and that you dispose of the array that we're going to create here in a second. Because there's no garbage collection, you have to manually handle deallocating all of your arrays, or else you'll start having memory leaks and things will go bad. So the transforms array that we are going to be using, it's a new class that you get from using UnityEngine.jobs and Unity.jobs. And what this does is this takes the transform class and it trims it down to something that you only really care about, which is really just the position and rotation. And this is how you actually go about initializing that array. Then in update, the first thing we want to do is make sure that our previous job was completed. So before anything else happens, it will wrap up anything that it was doing, because you don't want to go off modifying your array while you're actually performing the job. The only thing I'm doing here is when you hit spacebar, it's just going to add some ships. Then we will make a new job, which we're just giving it a move speed, the top and bottom of the screen, and delta time. Because the jobs aren't going to be executing on the main thread, it has no concept of the time class, so you can't do time.delta time. We'll have to pass that in. And this job is really only going to exist for this one frame. That's why we call a new one every frame. After we've created a new one, we pop it on the scheduler, and then we call the job handle and schedule batch jobs. This will schedule all of our jobs, and it also handles delegating it out to all the threads. And then we have our add ships function, which is, again, you want to make sure that your previous job was completed before you add anything to it. Then what we do is we will basically just add our amount to it, which I think I'm doing 500. So that just increases the length of our transforms. Then we iterate them through them, and we just instantiate them. And that's just your normal instantiate prefab that we're all used to. And then we will add that transform into our transform access array. And yeah, well, that actually finally made up. So let's see. We started at what? 5,000 was the last one? Oop. So right now I'm at 40 frames a second, which is not amazing, but we can probably add okay, so we are at 7,000. And I think I can pop open the profiler. So you can see we're still getting pretty capped with the renderer. And well, that explains that. It's still using my Intel graphics. Huh. I know there's a way to actually force it to use your big boy card.
Still though, on integrated graphics, I mean, there was a very distinct performance improvement.
Yes.
It wasn't massive, but it was there. And was that with both ECS and the job system? Or just
This is just the job system.
just the job system? Okay.
Yeah. So let's see if I can just open it from these packages. All right, and now for the actual ECS stuff. This is using the hybrid approach. For our ship here, this is not actually going to be in the game at all. This is more of a prototype for our ship object. They actually call them archetypes when you're building it in code. And your archetype is just a collection of components that's going to represent an object. So our move speed component, this is basically it. It just inherits from the interface component data, and it has a value. For our movement speed, that's all we need. We don't care about anything else. This class only exists here so we can throw it onto a prefab. If you're using pure CES, you don't even need this. So it's just a struct with a value in it. It's serializable just because we need to see it in the inspector. Now, the movement system gets a little weird. This is also a struct, and it implements the iJob process. This interface is, they call it a filter. So what it will do is it is going to search your entire scene for every entity that has a position component, a rotation component, and a move speed component. It doesn't care what it is. If it has those three, this job is going to work on it. We're going to pass it in the top of the screen, bottom of the screen, and the delta time. This execute is what's going to happen once for every job. And it's basically the same thing here. We are getting a reference to the position, the rotation, and the move speed from up here. So we don't have to actually pass it over to it. The rotation and the move speed, we've marked them as read-only because we're not actually going to do anything with them. We just need to read it. So you don't accidentally mess with the rotation if you don't mean to. This float 3, this might look weird to you unless you have messed with shaders at all. This is from a new namespace, unity.mathematics. This actually is closer to Shader Lab and HLGL? GLHL? Don't quote me on that. But I'll show you at the end here, probably about another 15 minutes or so. This is actually to pass jobs over to the graphics card. That's what they call their burst compiler, which is actually really cool. Everything else is about the same. We're just taking our value, which is our position. We're doing the same thing, our delta time, speed. Since we don't have transform.forward, we are basically using the math library here to just calculate it ourselves.
So, dumb question real quick. That float 3, I'm assuming that's like for your X, Y, and Z coordinates?
Yes.
Got it. Okay. I can make that.
There are, there's float 2, float 3. There's also matrices. There's floats 3x3, 2x3 for your transform mathery stuff. And also we have a job handle here. The job handle isn't strictly necessary, but it's good to have an actual handle for stopping and starting your job, seeing when your job is completed or not, that kind of thing. It's also good for dependencies. If you have jobs that you need to happen before or after other jobs, that's what these dependencies are for. And down here is how we schedule the job. We are scheduling this job. This second parameter here is how many chunks you want per thread. Right now we're using 64, and also our dependencies. And this is where it gets really wild. So in our game manager here, we have an entity manager. This is getting set by a new variable they have. It's a world static class, I guess. And it will get or create one. So it's kind of like a singleton of your entity manager. The entity manager is basically will run kind of in the background. You don't have to do anything for your systems to run. The entity manager will find them in your project and run them. Again, we just have our regular add ships. Here, before we add the ships, we're going to add them into a native array. Native array is a new class in Unity.collections, and it is going to allocate an amount, and this temp allocator means that it is only going to exist in this class. There's also I forget what the other one is called actually. Persistent. And also temp job, I think lasts just for the job that you're in. And again, we just pass it in our XYZ values. Here, we are going to be setting our components for our entities. So the way that the component system keeps track of its entities is by its position in the entity array. So every index, every item of the same index is going to be the same object. It's a lot to get your head around, but just know that every I is going to be the same object for position, rotation, and move speed. Each one of these is going to be its own separate array. And then once we're done dumping our entities into our array for the manager, you have to make sure that we dispose of it. Otherwise, you get bad stuff happening, and Unity will yell at you. So we made it up to what, 9,000 last time? So here we are with 7,000, and I'm getting 130 frames a second. So 9, 10. 20,000.
That's nuts.
30,000. Yeah. Oh, also, because these are not game objects, you'll notice they're not showing up in the hierarchy. They'll show up in the Entity Debugger. This is one of the things they have to actually work on. So this is showing every entity in our game right now. With the Entity Manager, you can see our movement system. So each system, you can see what components that they're working on. So our mesh instance renderer, our movement system, you see our like forward 2D system. It's there, it's running. I don't have any transform 2Ds, so actually it's not running, but it would if I had any. And let's check out the profiler again. So as you can see, our rendering isn't nearly as topped out as it was before. But on the flip side, you can probably hear my laptop right now. So now that was actually without the burst compiler. I'm not sure how much of a increase this will get us. I've never actually used the burst inspector before.
Turn it up to 11.
Ooh. I am not smart enough for that. Their burst compiler is how they're going to go from C# to assembly, which is how they kick it off to the graphics card. So I started off here with 30,000. So this is at 40,000, and it's still in the high 20s. It's respectable. And as you can see in the scene, these are just 3D ships. Now, one thing you do have to do, your materials that you use for this, they have to be, you have to check this enable GPU instancing. If you don't, Unity will yell at you. So when I was saying that it's limited right now, about the only thing that you can do with this is move transforms. You can do surprisingly a lot with that, but there is no physics right now.
What about animations? Like, say I wanted to have like tens of thousands of like zombies walking around. Can you hook that up to the animation system?
I'm glad you asked that. Because they like literally as an hour before we got here.
No way.
They haven't done anything yet, but 4 hours ago,
Oh,
they
that's
opened an animation job sample. So nothing's there yet, but
I'm thinking about it.
it will be.
Oh, that's great. Ooh,
So
excited.
yeah, eventually everything is going to be moved over here. Their big thing is they want one way to code everything. So last month when we did the UNet thing, throw that all out. That's garbage.
So I did notice at the beginning of this, you said one of your slides was titled "Old and Busted." Does that mean eventually?
Yep.
Oh, that sucks.
Eventually, they still use the legacy animation system from like 6 years ago. So
I guess they did just retire. What was it, JavaScript like last year?
yeah.
All right, then I feel like
So yeah, that's actually that is about it. But I want to try to open one of these demos. I should have unzipped this before I got here.
Alright, just do it live.
Right.
Demo gods will be fine with that.
This is the Unite Austin demo. The one with the arrows and
the
the
bridges and the...
yes.
Oh, load. That'll be great.
And hopefully it doesn't blow up my laptop.
Where did you get that demo? Was it just on their GitHub?
It was actually on their ECS page for their Learn thing. Check it, pull it up. It was here. Features / jobs system ECS, and it's this one right here, Austin Technical Presentation.
Alrighty then.
They also have a really cool demo using voids for flocking. It's pretty cool. I know, right? This must be huge. Once a month. Let's see. Yeah. Next week? We got those scheduled once a month too.
Yeah, we also have a Telegram or Discord, whichever chat platform you prefer. You can just hop
Yep.
in there and help us and if you have questions.
Yep, our Discord is here for you people. It's Memphis Game Dev
My
Developers.
phone's literally about to die, otherwise I would.
It should be there. It's also on the meetup page. First comment there. The 20th is the social. We meet up at Dave and Buster's. And on the 7th, we got another open house. Oh, this is never going to finish.
This is good though. I like that. I have to spend some more time making this. That straight pushback.
Yeah, I mean we are basically done. I'm just gonna show off some fancy stuff, maybe. And it'll be no worries.
Yeah, I was. Thanks for the stuff. Oh yeah. Swag on the table.
Yeah.
Awesome. So yeah. I guess I'll stop the stream.